This is the second video for the Chapter 5 notes. We are starting at the top of page 7 with an example. The example says, according to flightstats.com, American airline flights from Dallas to Chicago are on time 80% of the time. Suppose 3 flights are randomly selected and the number of on-time flights is recorded, round 3 decimal places. Part A says, explain why this is a binomial experiment and compute the probability for each value of the random variable x. So first of all, we have a fixed number of trials, and our fixed number of trials would be n is equal to 3. Those flights are independent of one another. They have nothing to do with one another, so they are independent. The third thing is that we have to have 2 mutually exclusive or disjoint outcomes, and so those are going to be that the flight is either on time or it's not on time. And then the last thing is that we have a fixed probability of them being on time, which we do, which is 80% of the time, or 0.8. So from here we need to talk about the probabilities that we have to do for each of the random variables x. So x is going to take on different values, and this is going to be the number of flights that we would have on time in all situations. So either we have no flights on time, 1 flight on time, 2 flights on time, or all 3 of those flights would be on time. So from here, part A is asking for us to compute the probability. So we're going to have to compute the probability that no flights are on time, the probability that only 1 flight is on time, probability that 2 flights are on time, and the probability that all 3 flights are on time. So in order to do these all, we are going to have to use our graphing calculator, and the function that we saw up above on the previous page is going to be binom PDF. And the reason why it's PDF is because you have equals in all of here. It's exactly equal to 0, 1, or 2, or 3. So for all of these, we're going to be using binom PDF. And so for this, it's going to be the number of trials that we have, which is 3. Our probability, which is 0.80 or 0.8, and then our x value, and in this case x is equal to 0. On the graphing calculator, we're going to go to second vars, and from second vars we are going to go to binom PDF, and make sure you go to the one that says PDF, and then from here we need to enter in our number of trials, which is 3, comma, and the comma again is above 7. The probability is 0.8, comma, and then our x value, which is 0. Close your parentheses and then hit enter, and we get our probability. And from our graphing calculator, we get 0.008. For the next one, we are going to do the same exact thing. It's going to be binom PDF. Number of trials is still 3. Probability of being on time is still 0.8. However, now x is equal to 1. On the graphing calculator, we're going to go to second vars, go down to binom PDF. N is our total number of trials, which is 3, comma, our probability, which is 0.8, comma, this time our x value is 1. Close our parentheses, hit enter, and we get our probability. So from the graphing calculator, we get 0.096. So there's 2 more here to do, and both of these are going to be binom PDF. And number of flights is still 3, probability is 0.8, and for the second to last one, x is equal to 2. And then for the last one, we have 3 flights, 0.8 is our probability, and for this one, x is equal to 3. So take a second to try both of these on your calculator and see what answers you get and round them 3 decimal places. The last 2 probabilities, we do need to go to binom PDF for both of them. And to do that, you need to go to second vars. Remember that n is 3, our p is still 0.8, and then for both 2 cases, we have different x values. One of them is 2 and one of them is 3. From the graphing calculator, the probability that x is equal to 2, we get is 0.384. And then for the last one, the probability that all 3 of those flights are on time, or the probability that x equals 3, we get 0.512. Part B says to construct a probability distribution. Again, the word distribution just means table. And we actually already have all the values that we need. We've already calculated everything. This is going to be x, our random variable, and the corresponding probabilities. So looking at part A on the left, you'll notice that x takes on the values 0, 1, 2, and 3. And then the corresponding probabilities, we've already calculated those using Binom PDF in our graphing calculator. And so I'm just going to copy those down. And a couple things to note here is that this does satisfy those three requirements that we have for our probability distribution. X, our random variable, is numerical. If you were to add up all those probabilities, you do get that they are equal to 1, and all those probability values are greater than or equal to 0 and less than or equal to 1. So right below this we have another example, and it's using the same information but expanding on the example that we just had. So this one says, according to flightstats.com, American airline flights from Dallas to Chicago are on time 80% of the time. Suppose 15 flights are randomly selected and the number of on-time flights is recorded, round 4 decimal places. So again, we have n equals, and this time it's 15. And our corresponding probability that we have for it being on time is going to be 0.8 or 0.80, it's 80%. And so the first thing on here, part A, says find and interpret the probability that exactly 10 flights are on time. So it says exactly 10 flights are on time. So this is going to be the probability that x is equal to 10. And since we have an equal sign in here, where x is equal to 10, we will use Binom PDF again. And our n value, total number of trials, is 15. Probability is 0.80. And x in this problem is equal to 10. On the graphing calculator, we're going to go to second, vars, Binom PDF. Our n value is 15, comma, our probability is 0.8, comma, and then our x value for this one is 10. Close your parentheses, select enter, and then round your probability correctly to 4 decimal places. From the graphing calculator, we get an answer rounding 4 decimal places to 1032. And it also says to interpret. So this is the probability that exactly 10 flights on time is 0.1032. You can also rewrite that as 10.32%. Part B says find and interpret the probability that fewer than 10 flights are on time. So this is where we start using those words that we saw in the table earlier. And so for this one, fewer than 10 is going to be x is less than 10. And the only issue that we have is that for Binom PDF, that has to be an equal sign like we did in part A. But for Binom CDF, that one has to be a less than or equal to symbol. So since this is less than 10, we're not including 10. So the next whole number that we have would be less than or equal to 9. And so to do this on our graphing calculator, we're going to use Binom CDF. And this is going to be our number of total flights is 15. Probability is 0.80. And for our x value this time, the largest value that we have is 9. On the graphing calculator, for this one, we're going to go to second, vars, Binom CDF. Make sure it's the CDF, the cumulative distribution function. And our value of n is 15, comma, our probability is 0.8, comma, and then for our x value, the largest that we have is 9, and so that's the value that we're going to put in there. Close your parentheses and then select enter, and we get our probability, again, round 4 decimal places. From the graphing calculator, we get an answer of 0.0611. And then to interpret this, this would be the probability that fewer than 10 flights on time is 0.0611. Part C says find and interpret the probability that at least 10 flights are on time. So at least is going to be greater than or equal to 10. But again, for binom CDF, we have to have a less than or equals to symbol. And so remember that we wrote down the complement with this. This is going to be 1 minus the probability of what we do not want. And for this case, it's going to be x is less than or equal to 9. And we just calculated this probability x is less than or equal to 9 in part B. So we do 1 minus 0.0611, again getting that from part B. And subtracting this on your calculator, you get 0.9389. And then to interpret this, this is the probability that at least 10 flights are on time is 0.9389. Part D, the last part that we have here, says find and interpret the probability that between 8 and 10 flights are on time. And so for this is going to be the probability that x is going to be between 8 and 10. And so this means 8 flights are on time, or 9 flights are on time, or 10 flights are on time. So we can find this by calculating each of these. So x is equal to 8 plus the probability that x is equal to 9 plus the probability that x is equal to 10. You could also do this using binom CDF, but a lot of students find it easier to use binom PDF in these cases with between. And so we would have to add these all up and do this 3 times. So it's going to be binom PDF, 15 flights, 80%, the first one x is equal to 8, plus binom PDF, 15.8 and 9, plus binom PDF, 15, 0.8, and 10. To calculate the probability, we need to go to second vars, binom PDF, and we're going to have to do this 3 times. So for the first one, our x value is 8, but the n never changes, that's still 15, and our probability never changes, it's still 0.8. But again, the first x value we have is 8. Close your parentheses, plus, we're going to do this again. So I'm going to hit second vars, binom PDF, 15, comma, 0.8, comma, and then this time our x value is 9. Close your parentheses, plus, and then one more time, second vars, binom PDF. Still our n is 15, our p is 0.8, but this time our x value is 10. Close your parentheses, select enter, and then make sure you round your probability correctly 4 decimal places. From the graphing calculator for this problem, we get an answer of 0.1600. And so to interpret this, this would be the probability that between 8 and 10 flights on time is 0.1600. Right below this, we have the mean or the expected value and the standard deviation of a binomial distribution. So a binomial experiment with n independent trials and a probability of success p has a mean mu equals n times p and a standard deviation sigma equals the square root of n times p times 1 minus p, which is also equal to q. And so definitely some formulas that we do need to know. It says it is very important to interpret and understand the mean and the standard deviation so that the range rule of thumb can be helpful. And so reminding us of what the range rule of thumb is, this is where things are significantly low, significantly high, or values that are not significant. And that's within those 2 standard deviations of the mean, the same thing that we've seen in the past few chapters of notes. So the example right below says between 1987 and 2024, there were 460 NFL football games that were decided in overtime, and 252 of these were by the team that won the overtime coin toss. Assuming that winning the overtime coin toss does not provide an advantage, then P is equal to 0.5 and Q is equal to 0.5. Round 2 decimal places. Part A says find the mean and the standard deviation and the number of wins in the group of 460. So again, we're asked to find the mean and the standard deviation, and those little formulas are given to us at the bottom of the previous page on page 7. And so we know that the mean is mu is equal to n times p, and the standard deviation is sigma, which is equal to the square root of n times p times 1 minus p, just copying down those formulas from up above. And so with this, we know n is the total number of games that we have. It's a group of 460. And p is going to be that probability of winning, and it does say that p is equal to 0.5. So substituting these in, I can calculate my mean, which works out to being 230, and this is games. And then on your calculator, we have to do the square root of n, which is 460, times 0.5 times 1 minus 0.5. On the graphing calculator, we need to use the square root function. The square root function is with x squared. It's right above log. It's on the left side of the calculator. To get to the square root function, we need to select second, x squared, and it should put a square root function on your calculator. From here, you type in exactly what we have, which is 460 times 0.5 times, and then parentheses, 1 minus 0.5, close parentheses, select enter, and from here we get our standard deviation. So from the calculator, we get an answer of 10.72, and this is games. Part B says use the range rule of thumb to find the values, separating the numbers of wins that are significantly low and those that are significantly high. So for significantly low, we have mu minus 2 sigma, and for significantly high, we have mu plus 2 sigma. We just calculated mu up above as 230, and the standard deviation sigma is 10.72. So let's do significantly low first. So this is going to be 230 minus 2 times 10.72. And when you work this out on your calculator, rounding 2 decimal places, you get 208.56. And we're going to say this is games. So you can, for significantly low, it's going to be 208.56 games or less. For significantly high, we have 230 plus 2 times our standard deviation, which is 10.72. And when you substitute that all in on your calculator, you get 251.44. And again, this is games or more. Part C says, is the result of 252 overtime wins in the 460 significantly high? And so if you look at significantly high that we had up above, it was 251.44 games or more. And so since 252 is more than 251.44, this is significantly high. And the reason why is because 252 is greater than 251.44 games. So right below this, it says we can use probabilities to determine when results are significantly high or significantly low. So we did it up above in this previous example on part C, and using part B is using those cutoffs of mu minus 2 sigma and mu plus sigma. So we can also use probabilities to determine exactly the same thing. So a significantly high number of successes, X successes among n trials, is significantly high if the probability of X or more is less than or equal to that 0.05. Likewise, significantly low number of successes is going to be when the probability is x or fewer than, is less than or equal to 0.05. So the big thing here is that probability has to be very unlikely, very small, and our number that we have is smaller than 0.05. The example right below says data on M&M weights contains information on 100 M&M candies, and 19 of those are green. Mars Company claims that 16% of plain M&M candies are green. For the following, assume that the claim that 16% is true and assume that the sample consists of 100 M&Ms. It says round parts A and B 2 decimal places and the probabilities are in parts D and E 4 decimal places. So part A says find the mean and the standard deviation for the green M&Ms in a group of 100 M&M candies. So for this problem, our sample size that we have is 100, and our probability of being green is 0.16 is what the company says. You always want to go with that probability being what is for the population, and for us it's 16% is what the company is saying. So to calculate our mean, from the previous page we have n times p, and our standard deviation is a square root of n times p times 1 minus p. So substituting in n and p that we have, we can calculate these. So 100 times 0.16 is 16, and this is M&Ms. And then to calculate our standard deviation, we have the square root of n times p times 1 minus p. And when you calculate this, it does want us to round 2 decimal places. We get 3.67 M&Ms. Part B says use the range rule of thumb to identify the limits separating the values that are significantly low and those that are significantly high. So in order to do this, we have to use our cutoffs that we have, which are going to be mu minus 2 sigma, and this is again for significantly low. And for significantly high, we have mu plus 2 sigma. And we just calculated our mean and our standard deviation right up above. So we have 16 minus 2 times 3.67. And when we work this out, we get 8.66, and this is or less. And what we're talking about here is green M&Ms. For significantly high, it's going to be mu plus 2 times our standard deviation, which is 3.67. Again, plugging this in on your calculator, we get 23.34 or more green M&Ms. Part C says based on the results above, is the result 19 green M&Ms significantly high? So if you look at what significantly high is, that means 23.34 or more green M&Ms. And so is 19 significantly high? And we're going to say 19 green M&Ms is not significantly high. This is because it is not greater than or equal to 23.34. Part D says find the probability of exactly 19 green M&Ms. So this time we're asked about the probability, and the word is exactly, which means equals. So exactly equals to 19. And to calculate this, we're going to use binom PDF. And you might ask yourself, why is this a binomial problem? A couple things. Remember, you have to check those 4 requirements. First one is that you have a set number of trials, and we do. It's 100. The trials have to be independent of one another, and they are. One candy has nothing to do with another candy. 2 outcomes. Since we're only talking about green, it's either green or it's not green. And then last one, we have a fixed probability, which is at 0.16. So we're going to be using binom PDF. We know our total number of trials is 100. The probability that we have is 0.16. And the value of x that we have is 19. On the graphing calculator, we're going to go to second, vars. Go down to binom PDF. Our n value is 100, comma, probability is 0.16, comma, and then our x value is 19. Close parentheses, select enter, and then round your probability answer correctly 4 decimal places. From the graphing calculator, we get 0.0736. Part E says find the probability of 19 or more green M&Ms. So 19 or more means that x is going to be greater than or equal to 19, which again, we can only use the symbols equal for binom PDF, or for binom CDF, we have to have less than or equals to. And since this is greater than, I know that we have to do 1 minus what we do not want. And what we do not want is anything less than or equal to 18. So we have 1 minus binom CDF, and for this we have 100 for n, probability is still 0.16, and this time our x value here is 18. On the graphing calculator, we need to go to second vars and go down to binom CDF. Our n value is 100, comma, probability is 0.16, comma, and our x value is 18. Close your parentheses and select enter. From here, we're going to do 1 minus, and then I'm going to round that answer up above to 4 decimal places, which is 0.7576. And then that would be my corresponding probability. From the graphing calculator, we had 1 minus 0.7576, which is equal to 0.2424. The last thing that we have says which probability is relevant in determining whether the result of 19 green M&Ms is significantly high. The probability from part D or part E. It says based on the relevant probability is the results of 19 green M&Ms significantly high. So 19 green M&Ms is significantly high means that it would have to be 19 or more. So for significantly high, we would have 19 green M&Ms or more. And that is exactly what matches up here with E. So this means that E is relevant. And then it's also asking, is the result of 19 green M&Ms significantly high? So this is not significantly high because our probability that x is greater than or equal to 19 is equal to 0.2424, which is larger than 0.05. So this concludes our Chapter 5 notes. Make sure to reach out if you have any questions.